Probability and statistics. Probability is the mathematical term for the likelihood that something will occur. We use probability in daily life to make decisions that we do not know for sure what the outcome will be. Statistics is the study that deals with the collection and analysis of data. Basically, it helps us understand the world a little bit better through numbers and other quantitative information. So, what are the usage of probability and statistics in general? Sport strategies. Sport coaches use probability to determine the best sport strategies for competitions. A football coach can evaluate a player's performance during training session. If a player makes 8 out of 10 goals attempt from the penalty box, he has an 80% chance of scoring on his next attempt from that distance. Next, we have weather predictions. Meteorologists can't predict exactly what the weather will be, so they will use tools and instruments to determine the likelihood that it will rain. For example, if there is a 60% chance of rain, then the weather conditions are such that 60 out of 100 days with the similar condition, it has rained. Insurance options. Insurance are also based on calculation rooted in statistics. You are able to secure your future better financially through various algorithms that you have a better idea on how to plan your life. For example, if 5 out of every 10 residents in your area have encountered fire disasters in the past year, you will likely want to consider buying fire insurance for your house.
Binomial distribution. If X is a discrete random variable that represents the number of success in n independent trials of a binomial experiment with P as the probability of success in each trial, then the probability distribution of X is given by the equation below. The characteristic of binomial distributions are: the experiment consists of n identical repeated trials. Each repeated trials have two possible outcomes, success or failure. The probability of success is represented by P and constant for every trials in n representation. The Bernoulli trial that is repeated n times are independent of each other. Poisson distribution. If X is a discrete random variable that represents the number of success occurring in a particular interval of time or specific region denoted by T, with constant lambda as the mean number of success per unit time or specific unit space, then the Poisson distribution of X is given by the equation below. The characteristic of Poisson distributions are an experiment where the number of success occurring is noted down in a particular interval of time or unit space. The probability of success occurring in a particular interval of time or specific region is the same for all intervals of the same size. The number of success occurring is random and independent of the number of success occurring in other intervals.
The next distribution is normal distribution. If X is a continuous random variable that has the graph of probability density function with the shape of a bell, then X is said to have a normal distribution with means and variance. The probability density function is given by the formula as shown below. The shape of the curve is as shown in the picture as well. The characteristics of normal distribution are: it has a bell-shaped curve and symmetry at the vertical axis passing the mean. And secondly, it has the x-axis as the asymptote. And next, it has the maximum point at the location as shown.
Good afternoon. One of the applications of normal distribution curve is to carry out quality control in industry sector. In normal industry, the weight of the product is not always the same as the stated weight. For example, in YTL cement factory, the auto-filling machine are normally distributed with a standard deviation of 0.05 kg. In order to maintain the reputation of the company, the amount of cement bags are set in a way that only 1% of the cement will have weight less than 50 kg. Hence, in order to do so, we need to find the mean weight of the cement bags. We are given that the standard deviation is 0.05 kg, value of x equals to 50 kg, probability of x less than 50 equals to 0.01. From here, we know that the value of z equals to negative 2.33, and then we sub this formula into px less than 50 equals to 0.01. Then we get the formula for the third row. And from the calculation, we know that the mean is equals to 50.12 kg.